My presentation is a simulation of a soccer game.
Let me begin this project by saying that I definitely have a passion for soccer and I really like the game. So this inspired me to do this project. So this software can be used as a training tool for soccer players of all skill levels. For example, beginners could be taught simple passing drills and the more advanced players could be taught the more complicated goal scoring techniques and also defenses to prevent them. So what I would need is a comprehensive variety of soccer drills and plays that are incorporated in the software, and this could be available to all interested parties. The intention is to make it ultimately available for purchase if possible. The example incorporated in the project shows a computer simulation of a simple passing drill and how this can be done through MLPQ and MATLAB. Let me begin by saying that this simulation will include half a soccer field with a goal in there, the markings, and a ball, and of course, players. The offense is moving toward the goal, passing the ball. The offense and the ball move, but the other items, such as the defense, are stationary. These will be used for Voronoi diagrams and other tests. This is what the map of the soccer field looks like before any animation whatsoever. The red squares are the defenders, which once again do not move. The orange is the goalkeeper, which also does not move since this is only a drill. And the yellow is the ball, and the blue are the attackers. Of course, if this was a real game, the defenders and the goalie would have actually moved, but this is not a real game. The universe is divided by a Voronoi diagram into three sections. Section 1 is the points closest to the goalkeeper. Section 2 is the points closest to the defender 1. And the third section is the points closest to defender 2. The goal has been transformed from vector representation, which is similar to a trapezoid, into a constraint representation. The half circle at the center of the field has been represented by piecewise linear approximation, and I used a tolerance of 0.2 by selecting 5 points from the right bottom quarter circle, and the right upper quarter circle has been drawn by linear symmetry with respect to the x-axis. The linear interpolation to determine movements for offense and the ball, and I also did 2D shaped function interpolation to approximate frequency of success per 100 kicks by scoring from a point xy on the field.
This is my animation of the passing drill.
This first query is to find the time that attacker A is closer to the goalkeeper than the two defenders. You might ask, why is this query so important? Well, it's very important because usually when this is the case, the attacker is offsides. Offsides is when a player is behind every single defender at the time of a pass. This is very important to analyze because whenever there's offsides, there cannot be a goal scored. And also it's a defensive strategy to make sure the offensive player is offsides so that they can't score a goal on you. Unfortunately, it's up to the referees to decide whether it's an offside, so that is risky, but still, it's good to analyze. This second query is to find the maximum likelihood to score from the center circle. This query is important because it tells you whether it's a good idea to try to shoot from the center circle. Well, since the maximum likelihood is 51.75 out of 100 kicks, which is around 52 out of 100 kicks, in practice, that's not a very good ratio. So it shows that it's much better to get in closer, which will have much higher probability to score. This query is to show the lowest point the ball has reached between time 2000 and time 2500. Why is this query important? This query determines what side of the field a team is playing on. If a team likes to play on the right side of the field, then as a defender, you would definitely encourage them to play on the left side of the field so that they score less goals on you. Query shows whether there was an attacker, or to list the attackers whose likelihood of scoring between time 1000 and 1500 was at least 30 out of 100. Now, why is this query important? Whenever an offense wants to be able to score as many goals as possible, it would want to give the ball to the proper person, which is the guy with the highest likelihood of scoring. If a team cannot score, and it's seen that all of their attacks are done by the players with low frequencies, they should definitely try to give it up in the future to the players with the highest frequency, which will result in more goals. This query answers the question, was there an offender whose closest member of the defense, including the goalkeeper, was defender 11? This is important now due to skill levels. Let's say that the best offender on the pitch is offender 9. As a defense, you would want defender 11 to be close to offender 9. On the other hand, for the offense, if offender 9 is the best offender, they should try to stay as far away as from defender 11 as possible to maximize their attack. Now let me talk about the data sources that I've used to make this project. I used a book called Step by Step Soccer, and the times I use it is to see some passing drills, what kind of passing drills are done. So I learned from there. I also used MLPQ to perform the programming. I had help from MATLAB to create the MLPQ code for the P-line approximation, the Voronoi diagram, and the 2D shape approximation. I also did calculations in Excel. This project is in its pilot stage, and it aims to demonstrate proof of concept. Well, what is the pilot project? The pilot project is the initial project that will determine a larger project's needs. And what is a proof of concept? This shows that this is a feasible project if given enough time. Now, to upscale this software and to incorporate many other drills is in principle done in exactly the same way. So, in conclusion, if given more time, and maybe if I had more people working on it, this could definitely become a major project to help soccer players learn soccer better.